Hello, 8th grade science. This is our first instructional video for Unit 6, Week 3, and this follows this kind of first activity called the Coriolis effect. So really the goal of the activity today is to learn what the Coriolis effect is, and if you look at the success criteria, you need to explain basically what causes it and how it impacts weather. So it can be a little confusing, the Coriolis effect, so your assignment, the way it's going to be set up, and I'll go through how to do it, is you have a bunch of different resources that are going to kind of explain what it is and what's going on. And don't stress too much on this because this is a very small factor when we talk about weather and climate. But it is important to learn because it kind of answers some questions I'm sure maybe some of you have, you just haven't really thought about them yet. If you look at our lesson plan portion for today, there is bell work linked. You guys can continue watching that El Reno tornado documentary. There's no explore because we have some notes. And I want to go through those now. So these notes are on the Coriolis effect and a little bit on circulation. So again, just like in the past, there's teacher notes or the slide notes, kind of whichever one you prefer. I'm going to open up the teacher notes, the PDF here, and just kind of explain in my words, based on your notes, what the Coriolis effect is, and then I'll go through the assignment directions in a different video after that. So when you open up these and fill out your notes, and it's loading really slowly. Drink my pop. Oh my goodness. Okay, I was about to pause. Okay, there we go. So the Coriolis effect. It's an apparent or a pseudo force. So it's not like a real, like gravity is a real force, right? If I drop something, something's going to fall. It makes it look like something's happening. I think this is where the confusion is, but it's not. It's more of a phenomenon, things that happen just because of nature. Okay, so it's an apparent force that makes things like planes and currents of air traveling the long distances over Earth appear to move in a curved line as opposed to a straight line. And you're probably thinking, what are they talking about? So what's actually happening here? So we know the Earth is rotating, right? Cool. If I am sitting on the Earth, I'm actually rotating with the Earth right now. You don't even notice it, because it's just something that we're just attuned to. But right now we're moving. Me sitting here, we're moving because the Earth is spinning, and that's how we talked about in the previous video. That's how we kind of get our day and our night cycle. Okay. Now, if I somehow am in a plane, let's say, or if I'm a cloud and I'm in the atmosphere, I'm no longer touching the Earth. Okay, I'm not tethered to it. The air, the atmosphere, it's just kind of like it's floating. It's air, and so because the Earth is spinning, and the clouds, in this case our weather or our plane, they're not touching that object, the Earth, the ground that's spinning. They actually don't spin with it, right? It's almost like if you imagine, so the Earth is spinning, here's a really good example. So imagine like you have a treadmill, right? And it's on and it's going, the conveyor belt, and then you have, you just hold your hand like above it, right? Pretend your hand's a cloud above it. While the conveyor belt is moving, that's like that ground that's moving, your hand isn't going to move with the conveyor belt because it's not touching it. That's the same thing with clouds and planes. And so when we talk about the Coriolis effect, the reason that planes and clouds, they look like they're going in these curved as opposed to a straight line, the reason that's happening is because we're still moving. And so when we look at these things, we're moving, but they aren't with the Earth, and it makes it look like it's going in a curved direction. It'll make more sense in the assignment too, but that's kind of the gist, right? One is touching the ground, which is moving, and one is not. If we look at this stuff up here, so in the northern hemisphere, objects like planes will deflect to the right. So when they're trying to travel, they have to kind of go towards the right to kind of keep going in the right path around Earth. In the southern, they do the opposite. They go towards the left. If we look at some of the weather, right? So storms, just think of like hurricanes, right? They're kind of that spinning circle. In the northern hemisphere, they spin counterclockwise, so opposite of a clock. But in the southern hemisphere, they spin clockwise. And that has to do with the fact that they're spinning as they travel over Earth, and the Earth is spinning, and they're not connected in that way. So it'll kind of, I think, make more sense when we look at your assignment too, because there's some videos that explain it probably better than me. That's why they're there. But hopefully you can kind of figure out, or at least understand, right, that the Earth is spinning, the clouds and things in the air are not, because they're not touching the Earth anymore, and that's kind of causing this force that we'll kind of look at and explore in our assignment. I will go through the directions for how to do that in the video down below, so make sure you tune in for that, and have a great rest of your day. Bye. Ooh, there we go.